Hi, my name is Michael Eiler. I'm one of the lab managers here at the Experiential Learning Center in the Electrical and Computer Engineering Department at Brigham Young University. This video is specifically tailored for the spring 2021 ECIN 240 students who are learning Eagle during the semester. It's going to be pretty informal. Hopefully I'm not making too many edits and making this too perfect. This is mostly just to give you guys a basic hang of Eagle. If you want more information, you're welcome to stop by the ELC and either ask questions or join us for our semester class about Eagle and circuit board design. So the circuit we're going to be designing today is fairly straightforward. We're going to start with our microcontroller. In this case, we're going to be using the AT85, the AT-Tiny 85, and we're going to power that with 3 volts, which is kind of right in the middle of its comfortable range. So we're going to have a 3-volt signal there, and our 3-volt power supply there, and ground. And we're going to pull off one digital pin. We'll take D1, and that's going to go to the positive input of our op amp. We're going to set this up as a constant current supply. So we have our current limiting resistor down there. We have a transistor up here, and that's an N-type transistor. And then we're going to have our 2 LEDs that we want to drive sitting above the whole thing. And those will be powered by a 6-volt as well as our op amp here. The op amp is going in single supply mode, so that'll be at 0 on the negative supply. And then this transistor that we're using is the 2N3904 transistor. And that's our whole circuit. Alright, so your first step is going to be going to your favorite web browser and just searching for download Eagle. Make sure that you go to the Autodesk website. As you can see, I've already been here because I already downloaded Eagle on this computer. But it's very, very operating system friendly. You select your operating system, Windows, Mac, or Linux, follow the instructions, and once you're done installing, you can sign in with your student account if you have one, which again I highly, highly recommend. But if not, I'll be doing everything on a free account just in case you don't have access to that. Alright, so now that I've fired up Eagle, I know it looks like I'm logged in, but I am offline, so this is only using the free options that you have. You'll be presented with this control panel. So this control panel gives you access to your libraries, whether you're downloading custom libraries from online or making your own parts, which we'll be doing in this series or in this video. It also gives you access to your projects. So down here, the first thing I'm going to do is I'm going to make a new project, and I'm going to call it ECE 240, that's good enough. And you can see there's this little green dot. That means that is my current active project. So in my active project, I could do things like create a new schematic, a new board, or a new library. Just like I was talking about, we're going to create a new schematic in this project, and it's going to pull up this screen for us. This screen is where we lay out the sort of human side of the circuit. So this is purely for visual and information transfer purposes. So we want to make this as easy to understand as possible and easy for us to use as possible. So we're going to start by turning on our grid, and we're just going to go with the basic units of 0.1 inches, and we want to turn the display on. So we're going to hit OK, and we have this nice grid now. And then we're going to go to Add Part. That's right here on the submenu. And this will allow us to add all the parts that we talked about in our circuit design. And there are 2 ways to search here. You can either search by the directory if you know exactly what you're looking for, or you can search for a specific part in this search window. So first, I'm going to search for a frame. So I know that's in the frame directory, so I'm just going to type FRA, and you can see it brings up the frame submenu. I open that by clicking that little down arrow, and I want an A4 size sheet of paper in a landscape format. So I'm just going to hit OK, and then you can see it's sort of following my mouse around. So I can left click to place it, and I'm going to place it right on the origin, that little cursor right there. I hit escape once, and that takes me back to the add menu. I hit it twice, and now I can kind of zoom out and see the whole sheet of paper that I want to work on. Now, if you notice, it says this is not saved. That's an excellent reminder. Fusion 360 is a cloud-based system, and so it will auto-save for you. Eagle is not. So you want to make sure you're always saving your work, because if you lose it, it sucks quite a bit. You can see this is saving it inside our ECE 240 project, but we want to give it a good descriptive name. So I'm going to call this Lab 6. And if I zoom out and zoom back in, you can see it auto-updated the last time I saved it, the name of the document, and the sheet number. We're only using one sheet for this, so that's all right. All right, now we can go and add our parts for the schematic. So the first thing we need, I'm going to zoom back out, or get back out of there, is instead of starting with the ATtiny85, I'm going to start with everything else and come back to that, because they don't have that as a default component or a readily available component. So I'm going to search for the op amp first. Now to do that, you're going to use what's called a wildcard. It's an asterisk, so you just do asterisk and then LM358 asterisk. And that basically says look for anything that has LM358 in the middle of the text. So it can have any text before and any text afterwards. And you can see our result right here. So if we click that, we're like, oh great, that's what we want, but we can't add that, right? If we try and hit OK, it says we need to select a specific footprint. And what they mean is, in Eagle, you always have footprints and schematics. So what we have on the left here is a schematic. Again, that's the human visual side. This isn't actually what it's putting on the circuit board. If we click on one of these, we'll see an example of a footprint. So this is a surface mount footprint. We don't want to use that. And if you look on the side here, you can kind of see the designation. We do want a dual inline through hole package. And you can see the difference between the surface mount are red and the through hole are green. So we want a through hole package. And this matches exactly what we have in the shop. So that's great. So we're going to hit OK. And we're going to place our one part there. And if we wanted to place the second part, if you notice, it tells you the pin numbers. So I hit escape twice to go back to this. And I have pins 1, 2, 3, 5, 6, and 7. Now you might be wondering, where's our power rail? Right? We need to specify that that belongs to pin 4 and 8 belong to 6 volts and ground. We do that with the invoke command. So I need to find that again really quick. It's right. Shoot. There it is, invoke. Okay. So we use the invoke command and we click on the anchor point, that little crosshair right there. And it says, okay, what do you want to pop up? And we say we want to use the power, or we want to invoke the power pins. And now we have these beautiful power pins floating around. So I can just click them right there. And now we have our pin 4 and 8. We hit escape. And if you're ever, by the way, if you're ever lost in Eagle, just hit escape a bunch of times. That'll take you back to the default. The default allows you to, drag objects around or do a box select and then drag multiple objects around. Escape is just your best friend here. It's really, really great. By the way, the middle mouse is scroll. And if I want to rotate something while I'm dragging it, I hold the left click or the left mouse button to drag. And while I'm holding that left mouse button, if I click the right mouse button, it will rotate for me. That's very, very useful. A little bit in the schematic layout, but definitely when you're doing the board layout. Okay, so I don't actually need this part, so I'm going to delete the other one, but I do need the power rail and the one amplifier inside the LM358. So I'm going to start with that. All right, now that we have our op amp on here, I'm going to go and add some other parts. So if you delete everything and then hit enter, it'll take you back to all of the options because it's searching for everything available. So we need a couple of resistors. Actually, we only need one. So we're going to go all the way down, and you could either type RCL. Well, you got to go a little faster, RCL. Or you could just look for the RCL sublibrary. We're going to expand that, and we want to look for the US style of resistors. And I'm going to double click here to kind of expand that menu out. And I can either go for the compact, what these numbers refer to, I guess I should explain that. So you have the O204 stands for the diameter and the length of it. And then the 2V stands for vertical, or the 5 stands for horizontal. The V stands for vertical. So if there's no V, then it's horizontal. So I find the ones that fit the best for me are the O2077 or the O2072V, which is a vertical package for the same one. So go ahead and pick whichever one you're going to use. I'm going to use the horizontal package in this case. And I'm going to hit OK. And remember from our schematic, we need one right there for our pull-down resistor. And that's it. I'm going to hit escape to go back to my menu. I'm going to close that submenu and close that submenu. Now I'm going to search for LEDs again. So I'm going to do star, LED, star, or asterisk. Right, you can see there's a lot of stuff going on here. I'm going to go down. I know it's a diode. That's not quite right. Here we go. LEDs. That looks a little better. Let's look at this. Aha, here we go. 3mm, 5mm, and 10mm. 10mm are pretty massive. 5mm usually work pretty well. So we know that we need 2 of those, and we want the cathode facing down. So I'm going to put one and the other one, just like that. Hit escape. And then let's search for the 2N3904. And remember, I have those asterisks before and afterwards. If you don't have those, it doesn't bring up all of the options. You can see one of those submenus disappeared. So these footprints, this is what's called an offset footprint. So the pins don't quite line up with each other. If we put those asterisks back in there, you can see this other submenu showed up, and this one has an inline package, and this is what we carry in the shop. So this is the one that we want to use. So I'm going to go ahead and put that right there. And we're almost done. The last thing we need to do is add our ATtiny85 and our battery connection. Before we can do that, we need to add an ATtiny85, because if we search for ATtiny85, you can see it doesn't bring anything up. And the size battery that we're using is a 2032. And if you search for that, although they have some, we don't have these style connectors, so we can't use these. So I'm going to go ahead and pause this and show you how to import a custom library and how to make a custom part. We're probably going to start with the custom part first. We'll make the ATtiny85, and then I'll show you how to make the battery packs, or import a library for the battery pack. So we'll go to that point. All right, I almost forgot. Before we switch over to the library, we need to save our work, because if something happens, we will regret it. Okay, so you can see I just hit Control S, or you can hit the save button, and it auto updates the time. It's 12:21. That's all good. By the way, to pan, I'm holding down my middle mouse button. This should have been mentioned earlier, but please don't use Eagle without an external mouse. You can, and that's fine, but it gets really rough really quick. So, all right, now that I've saved and closed my schematic, I'm going to right-click on my project, and you can see it's still active. I'm going to right-click and go to New Library. And what we're going to do here is we're going to add a symbol and a footprint for the ATtiny85, and then we're going to combine those to make a device. So let's start by adding the symbol. The symbol name, we can just simply call it the ATtiny85. It's going to say, are you sure you want to make one? Yes, we want to make one. That's fine. And if you scroll, there we go. We can make that window a lot bigger. And we need to add a couple of pins, so we're going to start with that. And you can see this is a fairly long pin. I don't usually like them that much, so I'm going to move over to the short pin instead of the middle. I want the short. And I'm going to go 1, 2, 3, 4, and right-click twice to rotate, just in case you forgot. And 5, 6, 7, 8, just like that. I hit escape once. And now I need to use the line tool, and this is just sort of to make a symbol of the box. And if you notice, you can do 2 lines at once, or if it's easier, you can just click on each corner. Hit escape, and that looks pretty good. Except for the fact that I couldn't recognize what that is. So what we're going to do next is we're going to right-click on this pin, and we're going to go to Properties. And this is technically an I/O pin, but more specifically, pin 1, if you remember, is a reset pin. Now that doesn't seem to be an option here, but because it's mostly just an input as P1, or as the reset pin, we're going to do that. So we're going to change the name to reset, set it as an input, and keep that. And then instead of visible, I really only want to see the pin name. So I'm going to hit OK, and now you can see it says reset there. If that's a little hard to see, you could just hit escape. Don't forget, if something weird is happening, hit escape. And just drag that up and drag that down. Now if you notice, I can box select the whole thing and left click on something, and I can then drag it around. So I want it to be right next to that origin. So that origin is in the bottom left corner. Alright, so that's the reset pin. let's click on this one. And if I just left click on it, it'll bring up kind of the description of that pin. So pin 2 is, for the ATtiny, is actually pin 3. So I'm going to call it IO3. This one is IO4. Whoops. IO4. This one is our ground pin. GND. That works pretty well. This one is IO0. That could get a little confusing, so I'm not crazy about that indication, but it's just going to work. IO1, IO2, and finally VCC. Or sorry, oops. Call it VSS. No, yeah, VCC. That sounds good. All right. Okay, it looks like we're kind of stepping on each other's toes a bit here. So I'm going to do a box select over just this area, and it will take the text with it. There we go. All right, this does it for our schematic part for the ATtiny. So I'm going to hit save, and now it's going to ask me to make a name for the library. So I'm going to call this ECE240. All right, so we've saved our symbol, the ATtiny 85. We could say that right there. Now we're going to add a footprint for it. And we're just going to call this a dual inline package, or DIP 08. And yes, we want to create a footprint called the dual 08. All right, so I'm going to go to the pad tool to make these pads. And you can see right now it gives me a square pad. That's fine if I wanted to. I'm going to go for this offset pad just because it gives me a little more room to solder to, but really this depends on what you're using. So sometimes people will use like an octagonal one to identify the ground pin. They might create a square one instead. They might use circular if they're trying to make things nice and tight. Or you might use an offset if you were trying to solder on a wire onto your board and you want a lot of extra space only in one direction. But in this case, we're going to use what's called a long pin. And so I know, oh, first off, I got to change my grid units on here. So grid comes on naturally for the board layer, or in this case, the board layer that we're using to generate our footprint. So I'm going to go to the grid, and I'm going to change this to inches, and a standard pitch or spacing between pins for most parts is always 0.1 inches. So I'm going to change that, and I'm going to change that. And the alternate grid, that I'll explain in a second, but this 0.1 inches, you can see it basically double the size of our grid. What that means is now when I put this down, I know that's exactly where those pins are going to be. So I have pin 1, 2, 3, 4, 5, 6, 7, 8. And with that, we're pretty much done. I'm going to add a line. You notice it's on the T-place layer. So this is more just a, no, I'm sure I'll go that way. So if you notice, it's only going this direction. So if I wanted it to go that way instead, I would go kind of like that. So it tries to understand what you're doing. Sometimes it gets it right. Usually it gets it wrong. But at this point, I'm going to close that off. And that would be good enough. You can add some text right here. So if I wanted the name of the part to show up, I would do that, but I need to change this to the tnames layer. And I could do the same thing. I hit escape once, and that takes me back to the text menu. I'm going to go to the value now. I'll put that down there. But, oh, whoops, that guy, if you notice he's on the tnames, he needs to be on the tvalues layer. So I'm going to do that. And this is done. So I'm going to save this and click this book to take me back to my library. So now I have a footprint for a DIP 8 package and the ATtiny, and I forgot the text on that, so I'm going to go ahead and add that super quick. Go to text, name, and change this to the names layer, and go to the values layer, hit escape, value, and I'll put that over there. Why not? Hit save, go back here. Now we have a name and value on the schematic and a name and value on the footprint. So now we're going to make a device that combines these two, and we're just going to call this the ATtiny 85. Yes, I want to make a new device called an ATtiny 85. Wants to be absolutely sure. All right, okay, so I'm going to add a part, and there's only one symbol that I can add, so that's nice. I'll put it right there. Hit escape twice to take me back to my default menu. That all looks good. Everything's nice there. But now we need to add a new footprint. So we're going to go here. We're going to say we want to add from the local package. And look, we only have one that we can add. So we're going to hit OK. And that pulls that up there nice and tight for us. But you can see there's a little warning here. If we click on that, if we double click, it'll bring it up for us. But what's happening is we need to connect the pins so they correspond with each other. So for instance, the reset pin is pin 1. So we're going to hit connect. Then it's pin 3 is pin 2. Pin 4 is pin 3. Ground is pin 4. And then pin 5 is, and if you notice, we keep the order right here. So it's 1, 2, 3, 4, 5, 6, 7, 8. So pin 5 is pin 0. Or digital output is 0. Digital input output 1 is pin 6. Input output 2 is pin 7. And VCC is pin 8. So those have all been connected. We're going to hit OK, and our little warning sign is gone. So we can hit save, go back to our library. Before we save this part, we absolutely have to go back and fix this. So we're going to open up our footprint again because we made our holes too small. So if you click on that, you can see, oh, come on, let me click on it. Nope. There we go. If we go down to properties, we can see that the drill size is only 23 thousandths of an inch, or 23 mil. So you could try and type in 40 mil, and actually that does work. But an easier way to do this is to use the change tool. So we're going to go change, drill, and then you probably won't have 40 there, 39.37, whatever is good enough. Then you could just go and click on all these. So you can see it's quite a bit bigger, and the reason why that's important is if those holes are too small, it actually won't fit the component. So now that that's done, we're going to save this and go back to our library and save it again. Now if we click on this device, it has both a symbol and a footprint. Whoop. I'm going to make that a little smoother for you. All right, so I'm going to save this library, and that's it for making our custom part. All right, so we've exited out of our library, and you can see it showed up inside our project folder, but that little dot next to it is gray, so we need to click that to initialize it and allow us to be able to see it. All right, so the name of the library is ECE240. So if we open up our schematic, turn our grid back on, and then go down to add a part, and search for ECE240. Hey, look, there's our custom library and our custom part. Nice. Doesn't quite look as pretty as the others, but that's okay. Will work just fine. I'm going to hit escape twice so I can kind of move it around a little bit. And you know, that looks pretty darn good. Our IO pin 1 is easy for us to connect. Now the only thing we're missing at this point is the batteries. So we need 2 battery symbols. And to get this, we're going to import a custom library that will be available on Learning Suite under the Lab Resources tab. All right, so I've downloaded the library from Learning Suite, and I'm going to right click here and copy, and then I need to navigate to my Eagle library folder. So that's in Documents typically, and then you go to Eagle and then Libraries. And then I could just right click and hit paste. You can see that library shows up. Now if I go back to Eagle, to my control panel, and I go up to Libraries, kind of like what we talked about earlier, you can see that that library is now shown up with the device that has both the symbol and the footprint. But just like before we can use these parts, I need to enable it by clicking that button. Turns green, and we're good to go. So now we'll go back to our schematic. We'll add a part, and we're looking for the 2032 library, which is right there. And remember, because we're using 3 volts and 6 volts, we need to have these together in series. All right, now these are all of the parts that we've needed to add. So at this point, we're going to kind of connect things together with the wiring, and that's going to be done with the net tool. All right, so all of our parts have been placed. I'm kind of move these around just a little bit. So with my box connect or box select, I can select that little anchor point right there and drag those up. And what that does is that just gives me a little bit more space to kind of work around. So I know that needs to be over there. That guy can move that way a little bit. Everything else seems to be all right. This guy is the label for that transistor. I'm going to move it a little closer just so it's a little more readable. And I think that's actually pretty good. Okay. So let's use this net tool. So the net tool allows us to connect different parts together. But one of the features of it is you can actually do what are called air wires. So for instance, and hit escape, or hitting escape will allow me to disconnect something. So for instance, if I start here and I go up to that, it'll automatically disconnect for me. But if I start on that and come over and I click, it won't let go until I hit the escape button, and then it lets go for me. But if you hit it twice, it goes out of that mode and you have to click net to get back in, or whatever feature you were going for. So that goes there. This goes there. That goes there. These are connected, and this is just following that same circuit that we laid out at the very beginning. So that's why I'm kind of speeding through this a little bit. That goes there. That connects there. That connects there. Hit escape. That goes there. And I think that's all the wiring. Okay, now let's explain air wires a bit, because you're looking at this going, okay, well, don't I need to connect my 3 volts together? Well, we can do that with what's called the name tool. So the name tool not only names components, for instance, like the ATtiny85, or the LM358, or the, instead of transistor 1, we'll call this 2N3904, 3904. But it also allows us to do things like name traces. So this will be 3 volts. And then if I click this and call that 3 volts, and it's going to warn me and say, are you sure you want to connect these? Yes, I want to connect them. And now those are connected, even though they don't look like it. This is one of those features where we talked about how it's a little different in a human readable format than it is on the actual circuit board itself. So I'm going to go ahead and label all of those. And every time you have duplicate connections, it's going to warn you just like that. Oh, I don't want to connect that to ground. That would be a little bad. I want that to be 6 volts. I want this to be ground. That needs to be 6 volts. And that needs to be ground. All right, now all of the tracing is done. The last thing I need to do is determine the value of resistor here. So if I have 3 volts at this point, because those are going to match each other when that's high, and I want 20 milliamps flowing through each one of these LEDs, that would be 20 milliamps plus 20 milliamps is 40 milliamps. So 40 milliamps with a 3 volt drop, let's see, 3 divided by 0.04 is the same as 300 divided by 4, which is around, oh goodness, math, don't fail me now. Let's see. If we divide it into quarters, that would be 25 times 3 is 75. Okay, so we need this to be a 75 ohm resistor. And we can label that with the value button. So the value button right here, we'll click on that anchor point and say 75. And now we know when we look at this that that needs to be a 75 ohm resistor. All right, this is all finished and ready for us to hook up. So let's go ahead and save it so we don't lose our work. And then we'll move into the board setting, and we'll use this button up here. And this allows us to switch back and forth between the board and the schematic. So don't feel like you have to finish your schematic before you move to the board, but make sure that you finish your schematic before you totally finish your board. Otherwise, you're going to have to redo your work. We'll click that button, and it's going to say there is no board file yet. Do you want to make it from the schematic? That's exactly what we want to do. So we'll hit yes, and it will bring up this new window. I'm going to make this a full screen. And you can see here we have a couple different things. So this is, it just kind of populates it populates a board shape for us to use, and it puts all our components off to the side. So what we need to do now is lay those out, and we'll do that in the next section. All right, so we're in our board file, kind of where we left off last time. The first thing I always do is I turn on my grid. So I change my units to inches, and I change that to 0.0 or 0.1. And I'll change my alternate grid to inches as well. And that alternate grid, what that does, oh, I need to turn my grid on, or display on. What the alternate grid does is, if you notice, if I drag this battery, and in order to click a component, you have to select its anchor point, which sometimes can be hard to grab. It's that little crosshair. That's why I always like to put it in the same spot every time, that bottom left corner. So when I move this component around, you can see it only moves according to each grid. I mean, that could be really, really annoying, especially if you need to do finer motion. So what I'm going to do is I'm going to hold that Alt arrow, and now it goes to my alternate grid. And so then I can place it exactly on those crosshairs, and I'm not worried about trying to fuss with that. But now if I'm not holding the Alt key, it'll let me go back to my gross movement. All right, so now that I've explained the alternate grid, let's go ahead and lay out a kind of a gross, meaning large, not gross isn't disgusting, a large layout for where our parts are going to go. And you can see these yellow wires represent the connections that need to be made, and they're kind of going everywhere. It's really ugly. It's not very clean. What's nice is, though, we can use a tool called Rat's Nest to help us sort of clarify what's going on. So if I hit the Rat's Nest key right here, it will go to the most orderly, I guess, or optimized layout. And you can see that cleaned it up quite a bit. All right, so I'm going to rotate that and put that there. And I'll take this guy and rotate it down here. What's a good spot for him? Oh, he's just going to the ground. Ooh. Okay. This is, for me at least, kind of the fun part of circuit design, because it involves a lot of just kind of puzzle work. You know, you're just kind of going in there and seeing what fits well and where exactly you want to place things. Now, if you notice, I'm using my alternate grid to move my components. So instead of the anchor being on the grid, I want my points to be on the grid. And that'll make sense in just a second. Because when I put this here, or I guess I'll explain it in a little bit. All right, and the reason why I'm kind of keeping this a little compact, also notice that you could do bulk rotations, which is very convenient in my opinion. All right, now this is getting a little ugly. But you can see, you know, I might move something and then decide, oh, I don't like it there. I want to move it somewhere else. This is really up to you. I'm going to get rid of this tag if I can. That guy. Because knowing that this is the ATtiny85 is really all I need to know. And then I have my LED 1 and my LED 2. That's great. And what I'm trying to do here is I'm trying to get it so I have the least number of crossing yellow lines. And what that does for me is it will make my job much, much easier when it comes time to actually laying out my components. Or sorry, not laying out my components. That's what I'm doing right now. It'll make it easier when it comes time to laying out like where the wires are actually going. Okay, so that looks pretty good. I'm gonna hit Rat's Nest one more time. You can see it kind of optimized it one last little smidgen for me. And at this point, I think we are ready to move into actual routing. And routing is when you're actually laying down where you want the wires to go. So this uses the route air wire tool. And there are a bunch of different things to understand to use this correctly. First and foremost, in the shop, we have a 0.012 inch minimum width. So I just like to set that right off the bat. And you want to make sure that this is on a 45-degree bend, because it's not very good to have your wire bends be 90 degrees. And then I always like to have my components on the top layer and my traces on the bottom if I can. So I'm going to select those three features. And the last thing I need to do is start clicking and sort of going over these wires. So you can tell right here, this is a 6-volt line. So if I click on that, it's saying, oh, hey, he wants to start laying this out. So I'm going to put one there. And it'll give you a little ding once it connects. That's nice. One there. And this guy goes there. And I think that's it for the 6-volt line. All right, now let's lay this line out next. Okay, so that's the 3-volt line, I think. Yeah, good. Okay, so a 3-volt line is going to go up. Just like that. It's also going to connect to this guy. Just like that. And if you notice, I'm ignoring the ground for now. And the reason why I'm doing that is I am going to use what's called a ground plane. So ground planes are very important for both decreasing or dissipating heat, as well as sort of just kind of decreasing the noise in your traces, right? So a wire in any direction will act as an antenna. And so if you have it next to the ground wire or ground plane, that acts in a capacitive role to decrease the noise on that signal. It's not perfect, but it really helps. So if you notice, I've routed everything except for that ground trace. What I'm going to do now is I'm going to use the polygon tool, and I'm going to change this to a 90-degree angle, and I'm going to lay this ground plane. And I need to give it the same name as my ground wire, which is GND. So I hit OK, and then I'm going to use the rat's nest tool one more time, and that's going to autofill my my traces right here, the last one. So all these ground planes are now connected. And at this point, this circuit is pretty much done. I mean, this wouldn't be great to spin around because you can see that those aren't concentric. You know, the board is balanced sort of well, right? We have our batteries on each side, and that's good. There's no room for the Hall effect sensor. We need to add a lot more. But this video is basically here just to teach you those basics. So the next step is to take this, and I'm going to do a big box select and drag it down to the corner. And what that allows me to do is then take this, which is my dimension layer for the board, and drag it down so it's right there. And if you notice, I've moved inside the polygon. That's fine. If I rerun my rat's nest, the polygon will show back up, and it just goes inside that board area. So I just need to drag that last one over and rerun my rat's nest again, and we're all finished. If you notice, there's not a lot of space between these, and that's actually another problem. So in the shop, you can use the shop cam file, or the shop design rule check. And we'll talk about that in the next section right here. All right, now that our board layout is mostly finished, we're going to go to the department website, so ece.byu.edu, and go to the Experiential Learning Center and Project Requests. From here, you can download the CAM file, which generates the data that we need to mill your board out for you. And you can also generate, oh, and I gotta change this to a .cam. Don't forget to do that, elccam.cam. And I can download the design rule, which needs to be at elc drc, which design rule check .dru. So I'm going to save both of those in my downloads. All right, in my downloads folder, we can see the elc.drc file. I'm going to open up my documents, Eagle, and right here I have my design rules and my CAM. So I'm just going to drag DRC into my design rules and my ELC CAM into my CAM folder. All right, now that I've installed my DRC file from the shop, I can click this arrow button to expand my menu and go down to the DRC check, or design rule check. You can also get this, by the way, if you go up to File, you can go to Tools, there it is, DRC. All right, so we want to go to we want to load a DRC, and if you notice, so it's right there, ELC DRC, and this essentially sets all the defaults for us. So like the wires have to be so far apart, they have to have a certain width or thickness, you know, all of that information. So we're going to run a check here, and in the bottom left it says no errors, but if you notice, that looks like a really thin line. That's because we need to rerun our rat's nest. And when we rerun it, all of a sudden that goes to a much more appropriate distance for us. All right, now that that's done, we can populate our CAM file. So we're going to save it like we should. Go to our CAM processor, and we're going to load a job file. So open a CAM file, and if we go to our CAM folder, we see ELC CAM right there. Open, and just process job. This is going to save it as a zip file, which I highly recommend, because then you can send this folder to us. Right here it is, right there. You'll fill out the project request just like you did for 3D printing. It will email you and you'll attach this zip folder. And we'll take that and process your board and email you when it's ready for pickup. This concludes our Eagle speedrun tutorial. This was far from comprehensive. There were a lot of edit mistakes and just like that. If you have questions or comments, feedback, if you have things that didn't quite make sense, reach out to the TAs or myself, or eventually any of the shop techs at the ELC, and we would love to help you work on your PCBs there. Thank you so much, and good luck with your projects.